Hello students, the only way to learn mathematics is to do mathematics. With this note, we are going to start today's lecture. In today's lecture, we are going to cover about basics of complex variables. This is a very important lecture for engineering student as well for BA Mathematics or BSc Mathematics. If you want to have a mastery on complex, then these basics you should know. I will cover these topics: complex number, a quick revision. Then we will discuss about complex variable. Then circles, disks, neighborhood and half planes will be discussed. And at the last, we will do some exercise to understand the topic. So please pay your good attention to this lecture because it's going to be the base of my next coming lectures. Complex numbers. Okay, let's start with one question here. How to solve x square minus 4 equal to 0? Suppose I want to solve this thing. X square equal minus 4 equal to 0. So to solve this, what I want basically, I want to solve x square equal to 4. What I'm doing here, we are looking for the x such x after squaring which I will get 4. After squaring which I will get 4. So I need the value of this x. I am searching this x. So think for some time, is there any real number, any number which you know that after squaring which you will get 4? Yes, 2 is there. 2. If I will square 2, I will get 4. Is there any other number? Yes, we have. Minus 2 is again there. If I will square minus 2, then I will get 4 here. So what we got as a solution of x square is equal minus 4 equal to 0, x equal to 2 comma minus 2 as my solution. It's very easy. So let's try one more example. Let me erase this first. Okay. Now in the similar way, I will solve in the similar manner. Let's try this question. X square plus 4 equal to 0. Then what I'm looking here, I'm looking for those x whose square is 2. Do you know any number which can be squared to get minus 4? Yeah, no, we don't have any real number whose square will give us a negative number. Because if I will go for minus 2, then square of this will become positive. If I will take any positive number, then square of any positive number will give me a positive number in case of real numbers. So at that point of time, mathematician thought that there is a need to extend this system of real numbers. In general, we can say that for ax square plus bx plus c equal to 0, this is a quadratic equation. If the discriminant b square minus 4ac less than 0, then we will not be able to solve with the help of real number system, or we can say we will not get any real solution. So what mathematicians done then? They have extended the system of real numbers and they introduced a new system that is called complex numbers. So for system of complex number, what we do here, we denote under root of -1 as I. If once I have denoted this, now I can solve this as well. How? Now I have, let me erase this. So now I can say that 2 iota and -2 iota is the solution of this, because once I will square this, let me square this, 2 into iota, so 2 square is 4 and iota square, as I know that iota equal to, so let me take it as iota square. So what I'm doing here, I'm squaring this, so 4 iota square, so this will give us 4 into iota square will be -1, so this is -4. Similarly, if I will square this, -2 iota, okay, I will get 4 -2 square, 4 and iota square -1, so this is -4. So what I got here, now I am able to solve x square equal to -4 as well, and but I got the solution in complex numbers, not in real lines. So this is how we have introduced system of complex numbers. Now let me give you a formal definition of complex number. Complex number Z is an ordered pair of a comma b of real numbers written as Z equal to a plus ib. Z equal to a plus ib. Or sometimes it is also denoted as simply a comma b. A comma b. This is a comma b, where the first, this part, this is known as real part of Z, that complex number. A is known as real part of the complex number Z, denoted by REZ. REZ means real part. So real part Z equal to A. Similarly, imaginary part is this B. So imaginary Z equal to what? B. So any complex number can be written as real part plus times of imaginary part. One thing you have to remember here, that A and B are not a complex number. They are not complex number. They are real numbers. But the combination A plus iota B will give us a complex number. So this is how complex number are introduced, and this is the formal definition of complex number. Next, let's see complex variables. What are complex variables? It is again very simple. Z equal to x plus iy. Z equal to x plus iy is called complex variable if this x and this y are two real variables. Okay, if x and y are two real variables, then we say x plus iota y is a complex variable. Means this should not be any number, this should not be any number, this has to be a variable, this has to be a variable, as well as this y has to be a variable. If these are two real variables, then we say x plus iota y is a complex variable. We will need some other basic definition as well. Okay, if z equal to x plus iy, then z bar is the conjugate of z is given by x minus iy. This is one thing. And the second thing is that mod of z equal to mod of x plus iy, it is given by under root of x square plus y square. We can see it in a figure. Suppose this is x-axis, this is imaginary axis. So let me take this as x comma y, this point. So what this is y, this distance is y, and this distance is x. Then this is mod of z. This is mod of z. What is the value of this? We can use Pythagoras theorem here. So this is equal to under root of x square plus y square. This is called modulus. Okay, this is called modulus. What is modulus? One more definition. This is what? This is origin, and this is that point, that complex number. So modulus means what? This tells us the distance of x comma y with origin. So modulus of z represents the distance between point x comma y and the origin. One more representation is there for complex number, that is called polar representation. In polar form, we will need Euler's formula. Euler's formula is exponential I theta equal to cos theta plus I sin theta. Okay, so z equal to any complex number in Argand plane is denoted by this, and in polar form is denoted by r cos theta plus ir sin theta. And suppose this is the polar representation, then in polar representation we represent this by this. This has to be straight line. Yeah, sorry. Yeah, this is r and this is theta. So r comma theta. Okay, so r cos theta plus ir sin theta. So x is, so yeah, after comparing these two, x equal to r cos theta, x equal to r cos theta. This is x and this is y. And mod of z equal to r. This is r mod of z, and it is what? This is x, this is y. So x square plus y square. And the theta is equal to tan inverse of y by x. It can. Okay, how to calculate this? Since I know, we know x equal to r cos theta, y equal to r sin theta. So y divided by x equal to r sin theta divided by r cos theta. It will give us tan theta. So this implies theta equal to tan inverse of y by x. So this is how we represent in the polar coordinate. I think it is clear now. Next we will need circle, disk and neighborhood. These all are new concepts here in graduation level. So let's understand them one by one. These are very simple again to understand. Consider some equations in complex plane. Okay, first equation I am considering here, mod of z equal to r. What it represents in complex plane. We are looking what it represents in a complex plane, mod of z equal to r. So from here it is little bit difficult to see. So let us convert z equal to what? X plus iy, expand it. So mod of x plus iy equal to r, and we I've just read that mod of z means what? Mod of z means under root of x square plus y square. So this will give us under root of x square plus y square equal to r. This implies x square plus y square equal to r square. Now what is this? This is equation of a circle with radius r. Equation of a circle with radius r. Equation, or I can say simply, this is equation of a circle. See, circle with radius r, and center. Okay, let me. Radius r and center. What is the standard equation of a circle? X minus a whole square plus y minus b whole square equal to r square. Then we say that the centers are a comma b. Here this is 0, this is 0, so center at origin. So if one want to draw it, we can draw it. Let me erase this. Now we are aware that mod of z equal to what? This is nothing but a circle of radius r. Now let's try this. Okay, again z naught is a complex number, another complex number, and z is x plus iy, a complex variable. So try this. Let's try this. Yeah, this one. So z x plus iota y minus x naught minus iota y naught. I'm taking z naught as x naught plus I naught. So this will give us this. This is equal to r. So this implies mod of this real part with real part. So x minus x naught plus iota times y minus y naught equal to r. So this implies x minus x naught whole square plus y minus y naught whole square equal to r square. So what we got? We got a circle with radius r, a circle radius r, and center. Can you tell me center? At x naught comma y naught. So center x naught comma y naught. Now we'll draw this. So with center z naught. This is the center and this is radius. So this is the circle. So this is center and this is radius. Radius is r. This is how we draw it. Next, now some more important concepts. Open circular disk. If we understood this, then this is very easy to understand. Open circular disk. Now we understood that what is Z minus Z naught equal to R? This is a circle of radius R with center Z naught. Now let me try this. So, this is, I'm drawing this first. So this is radius R and this point is Z naught. Now what about this? Z minus mod of Z minus Z naught less than R. It means the region inside the circle, the area inside this circle, boundary is not included. So how to draw that? Because that is not equal to 1. So to draw this, we draw it with dotted line. We'll draw it again one more time, no issues. So we draw it like this with dotted line, and we say dotted line means boundaries are not included. So this is open circular disk. Closed circular disk. This is what? This was circle only. This is circle. Okay. This is Z naught and this is R. And closed disk means this is Z naught and this is R. That this part is also included, including boundaries, but here only this part is included, excluding boundaries. Interior of the circle means excluding boundary. Closed circular disk or open circular disk means boundaries not included. That is open from the boundaries. Exterior, oh sorry, this has to be this. Exterior is this part out of this. If this is interior, then including boundaries, all the part, including boundaries, all the outside part is exterior. Means excluding the interior part. If we remove the interior part from the whole complex plane, then we get exterior. Now with the help of an open disk, now we understood that what is open disk. Open disk is a circular region excluding that boundary. This is sometimes also known as neighborhood. This is neighborhood of what? Z naught. Neighborhood means the nearby points. We are including nearby points actually. So neighborhood. So we call it as the neighborhood. Means the open circular disk is also known as the neighborhood of what? The Z naught, the circle, the center. If Z naught is the center, then neighborhood of Z naught. This is good. Depending on the R, because R can take any values. So if we are taking small r and Z naught is same, suppose Z naught is here and I am taking a small r, then this is again a neighborhood. This is also a neighborhood if I am increasing r. If I am increasing r more, then this will be also a neighborhood. Means neighborhood, Z naught has infinite neighborhood corresponding to different value of r. Means r has to be greater than 0. Means Z naught should have more than 1 point. Okay, this is neighborhood. So these all things you keep in your mind while solving questions. Next, annulus and half planes. It's again, if once we understood that interior, exterior and open circle, we will very easily understand this. Open annulus, circular ring. Mod of z, z minus z naught. First let me draw a circle. Okay, give another pen. Dotted circle, and we know that z naught is the center, so let me put z naught here. So z naught is this point. Now the region from here to here is annulus, but this is what? This includes the boundary as well? No, it should not include the boundary. If it is not including the boundary, then open annulus. If it is not including the boundary, if boundaries are not included, only these two regions, this region and boundary is not included, then open. If boundary is included, then closed annulus. Very simple. If boundaries are included, then closed. If boundaries are not included for the annulus, this region, then open annulus. Next, understand half planes. What are half planes? Half planes, this is x-axis, this is y-axis. Any point on this half, so this is, I can say that there are four parts. Upper part which is upper of this line, lower part, upper part, one part is here, that is right part, one part this side, left part. Very simple. So we can divide it into four parts: upper part, lower part, right part, and left part. That organ plane. We have divided organ plane into four parts. This is y-axis. Upper part, lower part, left part, and right part. Now what is upper part? Upper part is this part above x-axis. When I am saying our x-axis, means what will be the value of y if I am taking any point, any complex number here. So what will be the value of y? Y always will be positive. This y has to be positive here. So if y is greater than 0 for all x, for all z, then that is upper part. If y is less than 0, then lower part. If x is greater than 0, what? Right part, yes. If x less than 0, then left part. So I hope this is clear now. Circle, disc, neighborhood, open circular disc, annulus, closed annulus, upper half, lower half, right half plane, and left half plane. So let's do some exercise. Determine and sketch the set in the complex plane given by. The first question is mod of z less than equal to 4. So how to solve this? Try to memorize that thing, how we have done in my lecture. So let's try. Mod of z means what? Under root of x square plus y square less than equal to 4. If this is the case, then first take the equality sign only. First take the equality sign. Okay, whenever you come across such type of question, less than equal to or less than or greater than, so remove this inequality sign, convert it into equality, and draw that particular. So if I am dropping this inequality sign, so what I will get? x square plus y square equal to 16. So a circle with the radius of 4. I'm getting what? X square plus y square equal to 4. I'm dropping this here for some time. Okay, equal to 4. So this is a circle of radius 4 and center at 0, 0, 0, comma 0 are the centers and radius is 4 square. So radius is 4. Now what? Mod of z less than equal to. It's saying less than equal to. So this inequality is also covered now. So this represents the complete this part. That is a closed circular region. Okay, this is a closed circular region. How we draw it. These concepts are very important while solving question of integration. So we have to learn these, how to solve it. Next question. So question number B, you can do it your own. I will try question C. Question C, mod of z plus 2i. So here, if you are familiarized with this, so this will come like x square. Sorry, okay, let me do it step by step in C. Okay, I will, don't worry. Okay, so I will do it step by step. So how? Z is x plus iy and here plus 2 iota and this is equal to 1. This implies x plus iota times of y plus 2 equal to 1. This implies x square plus y plus 2 whole square equal to 1, because this is a modulus of under root modulus of this x plus iota y. So modulus of this equal to x square plus imaginary part whole square. Imaginary part is this is iota. So this implies what we got here, x square plus y plus 2 whole square equal to 1. What is this? This is a circle with center. Okay, try to find out the center. What are the centers? What is the center? 0 comma minus 2. Yes, 0 comma minus 2. X minus a whole square plus y minus b whole square equal to radius square, and radius will be 1. So we can draw it very easily now. Once center and radius are calculated, I can draw it in a complex plane. So this is center where at 0 comma minus 2 and radius is 1. Okay, if you want to draw it in the complex plane by making them, so take some suitable scale. Okay, let me show you what I am trying to say here. I mean to say we will need to draw it in complex plane as well. So this is real and this is imaginary y axis and this is real axis. So first draw the center 0, x is 0 and y is minus 2. So let me take this as 2. So x is 0, so this point is 0 comma minus 2 Now take a radius of 1 and draw the circle. So this is circle of radius 1. So this is how we do it. So it will be drawn here. So similarly, you try D and E. Okay, thank you.